Okay, welcome back. So we're slowly making our way through the chapter. It's heavy lifting, I'll grant you that. But here's the good news. I'm going to post any videos that are missing for any sections are going to be posted today or tomorrow, Thursday or Friday. Exam next week, and I'm going to pick questions that are out of the book. Okay? So basically, if you study the videos and you learn how to do each question in the video, you'll have an open goal. You'll just have to repeat it. That's going to have a fantastic effect on your learning because it's going to give you great motivation. And from experience, I know that you'll then be able to apply that to slightly different situations. It's not going to be too much of a challenge. Okay, so what are surds? Surds are square roots that do not rationalize. The best thing to do is start off with a non-example. This is not a surd because this is 4. Okay? Surds can be compound. They can have a rational part and an irrational or surdy part. Okay? It's that simple. Almost always, if you put a number here, it's going to be a surd, unless it looks like 4 or 9 or 16 or 9 over 4. Okay, that is not a surd because that's 3 over 2. Okay? And the sum of any rational number, just quick reminder now quickly of a bit of a set notation. Always nice to go through our set notation. The natural numbers are, the natural numbers are our counting numbers. The integers are all whole numbers with 0. We kick off here with 0. Plus or minus 1, plus or minus 2. The rational numbers are fractions of integers that don't divide by 0. So they are equal to the set of x such that x is an element of p over q for p, q. Best way, let me change. For p is an element of z because the top can be 0, and q is an element of natural numbers. Real numbers are everything on the number line. Okay, I don't really know how to do a definition. Real numbers equal x such that x is on the number line. Finally, irrational numbers. I don't think we really have a symbol for it. So we talk about or without q. Okay, and they form 2 families. They form the transcendentals because they transcend any form of logic. You cannot put manners on them. You cannot do something to them to turn them into rational numbers. So pi and e and the golden ratio, how do you write that? Something like that, are transcendental numbers. And then you've got a better behaved but not great set of surds. Etc. Okay? And if you add a rational number, now this is loosely defined because I'm adding sets here, but if you just think of q as being a rational number and you add it on to an irrational number, you get an irrational number. So if you add 2 and root 3, you get what's called a compound surd. Okay? And in particular, when we solve quadratics, compound surds come in conjugate forms. So So this will be conjugate with this. Their product will be rational, and their sum will be rational. Okay, now as often is the case, sometimes my theory at the beginning, which is extremely important for higher order thinking and for understanding, it may not have direct application, but it increases your understanding, and I hope you took most of that in. To multiply two surds, to take the square root of a product, you take the product of the square roots. Okay? So the square root of the semi-prime 10 is equal to the square root of 2 times the square root of 5. To take the square root of a fraction, it's equal to the fraction of the square roots. Now say this after me, pause the video. The square root of a product is equal to the product of the square roots. The square root of a fraction is equal to the fraction of the square roots. Okay? And if you have rational numbers times a common surd, then those rational numbers will add and subtract. So 2 root 5 plus 7 root 5 is 9 root 5. In reverse, the product of two surds is equal to the square root of the product. And you need to rationalize surds so that the bottom, what are they doing here? They're not doing that right at all. They haven't worked it out. Well, they haven't taken it home. I'll finish this for you. So if you have a compound surd under the line, you want to multiply it. Let me write it even better. If you have a compound surd underneath the line, you want to multiply it above and below by its conjugate. So you see, these two are cancelling. But when you multiply these two now, we find, that's the important thing about surd compound surd, conjugate multiplication, is that the product is not a surd, it's rational. Let's see why that is. I'm going to write it in this form to multiply it out. Okay, a by a. Come on, a by a is, you tell me, a squared. Plus by minus is minus. Root of b by root of b is b. Now we're noting a plus root of b times a minus root of b. A squared minus b. Hold on. What about our cross products? A root b minus a root b. Annihilate. Gone. So you have a squared minus b. So a quick test. What's 7 minus root 5 by its conjugate? 7 plus root 5. 49, take away 5, is 44. Okay? So yes, we can get conjugate products really quickly. Okay? You can also do them on your calculator if there's no letters involved. Okay? So you could do this on your calculator. 3 plus root 2 over 2 plus root 5. And I would have to say that's 2 minus root 5 over 2 minus root 5. That's not changing the answer to this original question in the red box. But I know I get 4 minus 5 at the bottom. And then I'm going to have to multiply out the top. And it's going to stay as a mess, if you like. It's going to stay as a surd. And it might even become a more compounded surd because there'll be root 2s and root 5s in there. But so be it. There's no other way. Well, except to use your calculator, which will do it for you. Which we'll do in a moment just to double check. So 3 times 2 is 6. 3 times negative root 5 is negative 3 root 5. 2 times root 2 is plus 2 root 2. But they're called unlike surds. They're not going to mix. And then you have minus root 10. All three of them are unlike. All divided by minus 1. So that's the holy mess you're left with. And there's nothing you can do about it. You get minus 6 plus 3 root 5 plus root 10 minus 2 root 2. We'll see. The calculator may just give us a decimal, but we'll give it a go and see what happens. We're going to put what's in the red box into the calculator. So we got our fraction bar 3 plus square root of 2. 2 plus root of 5. I'm not sure what's going to happen here. It might just say, okay, it went straight for a decimal. It's not putting it into, it's not putting it into exact form. But we can evaluate our exact answer and see does it turn out to be that. I'm going to store that to A, because we're going to lose it otherwise. Of course, I can scribble it down, but it's 1,042. Okay. So we have, let's do the negative bits at the end. 3 root 5 come out from under the square root plus root 10 minus, oh no, I'll come back on that, come out from under the square root. I'm going to use a bracket so that I can negate the two terms, okay? So I put a bracket now, and I have 6 and 2 root 2. Come out from under, close the bracket. 1.04. There you go. And I'll subtract A, and we should get exactly naught. Now we might get something very, very, very small. Now we get exactly naught. The calculator is behaving itself. Okay. So surds are fascinating. So you could use a calculator, and you probably should use a calculator, to be honest. Okay, this is square root of 16 by 5, which is the square root of 16 by the root of 5, which is 4 root 5. Express 4 minus root 5 squared. Well, we just multiply it out. Okay, we get 16 minus 5. We kind of picked that idea up from the last one, but we also have minus 8 root 5. And these talk to each other. They're like terms. So 11 minus 8 root 5 is the product. And a little take home there is the square of a compound surd is equal to A squared plus B plus 2A root B. Okay, now I had a negative in there which filters through there, but I'll take a simple example. 3 plus 3 plus the square root of 2 to be squared. We can say that's going to be 9 plus 2 plus 6 root 2. Okay. Take out the 4, turn it into 2. Leave him alone for a second. Take out the 9. No. When you take out 9, he turns into 3. 5 take 3 is 2 root 3, and the whole thing equals 1. Okay. A lot more heartache coming up here. To be honest, you just use your calculator but if you wanted a decimal. But if they said give it an exact form, you don't have any choice but to multiply above and below by the conjugate of this. Okay? Which is 7 root 13 plus 7 root 11 at the top. And the bottom is 13 take 11, which is 2. And that won't go any further, so that's your answer. You want to, you see, okay, let's go like this. This is 2 cubed. Or someone else might say it's 4 root 4 times 2 inside. Here you could go 2 squared times 2. And taking him out, you half the power. I want to find one with a lot in it. So 2. What are the factors of 200? No, it's 2 cubed. 8. Or is it 16? Only 8, I think. Look, reality is you're not going to have to do a whole lot of these in the exam. You'll be, they just don't come up, and if they did come up, you'd be using your calculator anyway. You know, you just do that. It tells you it's 20 root 5, so. Okay, there is inside there 3 squared 2, so it's 9 root 2. Two and 6 is 8, take 3 is 5 root 3. This is 3 root 2. You want to factorize 18 into prime factors. Now this is 2 to the 5 plus 3 squared by 2. Now 2 to the 5 is 2 to the 4 by 2. Okay, so taking this out equals 2 squared root 2. Taking this out, I'm just showing it to you in surd form, is 3 root 2, which is 7 root 2. Okay, I can leave those for exercises for you. Excuse me. No. Now we should learn how to, we should just learn the solution to this. It's very simple. Now what we've learned up to now, if we're to try and think what we already know, is to multiply this by the surd conjugate above and below. But you don't, there is a smarter way of doing it, because you don't need to have the minuses. Okay, so if you have just a single factor of a surd at the bottom, then you can go like this. And look what happens. Okay, so let's take an example. 1 over root 7 is root 7 over 7. So it's as if bring up the square root surd and put down the base. 1 over 3, root 3 over 3. Easy, yeah? So you can do that here to 2 upstairs as well. Bring up the square root 8 and bring down the base. Okay, now there's more to be done. 4. And this, of course, is 2 root 2. And finally, we're at root 2 over 2. Okay. There was other ways of navigating that as well. Okay. But it's as if that square root will go away and go up here. And you'll have 2 root 2 over 10. Easy. Now don't cross out those zeros, whatever you do. No way. Okay. So you go 20 root 50 over 50. Now you can take out the zeros. Now 5 comes out here. And you get 2 root 2. Seems like I've made a mistake somewhere. 2 over 5. Let's see. Seems okay. You can do your fraction bar after doing the denominator. 2 root 2. What did I get? I got 2 root 2. Fine. Okay. Some of these aren't worth doing really. Of course, you can also multiply in the 8 on the 12, but you're only going further away from your end. You're creating a bigger mess than you started with. So, like I just say it for all of these, unless there's some particular reason why we need them algebraically, use your calculator. Now, having said that, things have changed now because we're multiplying and dividing here in this question. It looks like my computer's down a bit here, guys. I'm sorry about that. We'll persevere. It's an important characteristic of good mathematicians. We have a productive disposition, and despite challenges, maybe disciplines, we keep going and have a kind of long-term view of success. It's very important you believe, confident yourself that it's going to work out. You have lots of time. Put away at bat all the time, and you make more and more connections. It's all about understanding. Now, what's important here, exploiting the square root of a times the square root of b equals the square root of ab. Okay? Or we just pop up root and start writing factors like 2 cubed and 2 squared from the 4. Okay? Now the 2 to the 5 is 2 to the 4 times 2 times 3. And the 2 to the 4 jumps out to become 2 squared. And the 6 is, which is 4 root 6. Well, this is simple. This is 3 by 5 by 2, which is our sphenic number 30. It's our lowest sphenic number, isn't it? If we don't allow repeats. 30. Sphenic number has 3 factors. Okay. We can do some reforming of, because this is root 2 by root 3. Pen is a bit fat, isn't it? Let's thin it down a bit. This is root 2 times root 2 by root 3 plus 3 by root 2. Well, he'll come in nicely by distribution, giving us 2 root 3 plus 3, 2. Okay? So it's 6 plus 2 root 3 is the answer. I hope you enjoy doing these. I argue that the idea of practice makes perfect mightn't be. Oh, look at this. This is lovely. They might be pitching it wrong and giving us too much work to do. But look, we know about the conjugate product of the null minus the base of the radicand. Uh-oh, there is no rational here. So what do you guess? Would you not say, it has to be 7 minus 5? You bet you. We love to do proof, direct proof. We want the general solution of this. Not that specific case with 7 and 5. That's not interesting. We want to know everything that looks like this. What's the answer? So we multiply these out. So I'll arrange it like this. We have A minus B, and the cross products are gone. So we have A squared minus, look at that, 4B. Because he was outside sneaky, so we had to square him. If you're not sure, we're to apply it out, but it's true. So we can do this, okay? The top will go plus root 2. And look, let's scratch that and call this 9 minus 2. Okay, so you have 36 plus 12 root 2 over 7. Okay, you have root 5 minus 1. You have 4 root 5 minus 4 over 5 minus 1. It's kind of cool there and interesting the way, yeah, it didn't matter whether he was being squared or not. And that's 4. So and those 4s go there. So be very careful. That means root 5 minus 1. Okay. Now, there's learning to be done here above and beyond the answer form that we're curious about. So we should investigate this one first. We have a very basic policy, simple policy. We know exactly what to do. Multiply above and below by the surd conjugate of the denominator. The surd conjugate of the bottom. Okay. Now we're squaring a minus b, because it's a minus b on a minus b, which we know how to do real quick. So it's a squared minus b over a squared plus b. It's 4 minus 5 over 4 plus 5. It's 9. And I think that deserves a quick look in the calculator for ourselves. 2 now minus root 5. I'm going to end up in a little bit of a mess here when I try to make a fraction. So let's start the ball here now a second. So let's not be so lazy that we're not going to hit this fraction bar first. 2. You should be going along with your calculator. Your calculator is an enormously important part of your preparation and your skills in leaving cert maths. You should always have it on the desk with you when you're working. Minus 9 plus 4 root 5. What did I say? I didn't say that at all. Minus 9 plus 4. So where did I go wrong? Oh, I see where I went wrong. I went wrong in the top multiplication. And again, this is a mistake, but the mistake is the biggest lesson you're going to learn today is that I decided to pull out my calculator and see was my answer right. And it wasn't. And so I hope you see the level of learning that's going on and the fact that mistakes are part of learning. It's just, that's what it's all about. So I made a logical mistake and a conceptual mistake when I multiplied them together. Cardinal error, if you like, mathematically. I should have got a squared minus b, and I forgot my two cross products. Now they're negative because there's a negative in there. Minus 2a root b. I left that out. The bottom bit was most likely correct. No, what am I doing here? First of all, this should be the conjugate. Okay. Sometimes you want to just start again. So I'm going to call this a minus root b over a plus root b. Now what do? We multiply above and below by the conjugate. See, I have a feeling I even made a mess of that. Now the bottom is certainly a squared minus b, and the top is a squared minus b, no, plus b, minus 2a root b. So we'll allow that get us our answer in this case, and then we'll go to the calculator, and we should be fine. So a squared is 4, plus b is plus 5, minus 4 root 5. That's the only surd is going to survive. And the bottom is 4 take 5. So we have 9. Well, we have 4 root 5 minus 9. And is that what it says in the calculator? It is. A little thought might be, sometimes you might want to learn what they're like, what's like in general. Then you might think, I could work it out each time. So here we're talking about 1 over a surd, a compound surd, minus 1 over its conjugate. Well, there's a few things we could do. First of all, we could write it as a single fraction and see what that does for us. So you'd multiply that by that. You'd multiply that by that, which is minus 1 by minus 1 is plus 1, and minus root 2. Okay, there you go. And you multiply that by that, which will rationalize. Root 2 by root 2 is 2. minus 1, and the cross products go. So the answer is 2. Okay, you might hazard a guess if it was 1 over root 5 minus 1 minus 1 over root 5 plus 1, would the answer be 5? Root 5 plus 1, 2. No, I think the answer would be 2 over 4. But anyway, we got the first bit right, and it's very interesting, isn't it? Yeah, so use the same method. If you have A over B plus C over D, you can say there's a D over D here and a B over B here. But what that is that by that plus that by that over that. Because there's your dB, which is common, and so on. You can track that through. So it becomes a multiplication plus multiplication all over multiplication. So that'll work out for you nicely. Oh dear. Well, they're conjugates. And if we're multiplying conjugates, the cross products are gone. So all we have to do is the firsts and the lasts. The firsts is 4 3's 12. The lasts is that. The answer is 7. That by that plus that by that over that by that. 4 plus 4 root 5. So that's another, no, 8. And 4 is 12. That's 2 root 5 over 4 minus 5. Hold on a minute. Can you get a negative number? Well, you can, because he's quite negative, isn't he? 4 over a negative. So, yeah. So, minus 12 plus 2 root 5. If you add with a common denominator, you can add the tops to get 8 over root 2. When you subtract, you can subtract the tops. You'll have a root 3 minus a root 3, which will be 2 root 3. Now we're not allowed to leave it either of them like that, remember. We have to put 8 to root 2. So 4 root 2. Remember, if we have a 1 over root a, it's got to turn into a at the bottom, root a at the top. They're equal. So when you see the root 2 at the bottom, he has to become a 2 at the bottom and a root 2 at the top, like I did here. And when I see this, I have to take him out, put 2 in root 2. Okay, the 2's cancel and you get root 6. When you multiply them together, it's quite easy. And when you divide them, well, when you divide two fractions, remember, turn upside down and multiply. So we're only going to have one floor here. I'm doing this one. You're going to have 4 plus, I hope you're not seeing the flicking screen that I'm seeing on my screen, root 2. And now we're flipping upside down. There will cancel. And 4 minus root 3. Okay, now we have 4 plus root 3. Now I had a way of dealing with this earlier, but I've forgotten, and that says it all. If I'm going to keep forgetting it, you're going to have to work it out each time. So 4 plus root 3 is the conjugate. 4 plus root 3 is the conjugate. 16 take 3 is 13 at the bottom. You definitely get 16 here. You get 3, and then you get 8 root 3. 19 plus 8 root 3 over 13. I wonder how close we are to the end. And you certainly get tired of doing them. If you look at the length of the video, I'd say you could probably multiply it by 2 or 3 for how much time you might need to dedicate. And make sure you're learning conceptually and that you can come back to the question 2 minutes later and do it without any help. You can do that yourself. Simplify. They might then take out the 5. But either of them, those answers are right. There's no difference. Well, what's our strategy? Are we going to need a 1 minus root 2 and a root 5 plus 1 at the bottom? And if that's the case, we're going to need the exact same up top. Now we know how to multiply them together really quickly. It's 1 minus 2. We know how to multiply them together really quickly. It's 5, take 1. The problem now is we've got 5 different compound surds, all of which need to be multiplied together. Well, good luck with that. See how you get on. I'll go down here. Write this as root 3 take 1 over root 3 plus 1. Okay? And we'll times above and below by root 3 minus 1. Bottom has become 2. The top has become 3 and 1 minus 2 root 3. 4 minus 2 root 3 over 2 equals 2 minus root 3, which is that. Well, as a single fraction, you've that by that. Whoops. You've that by that, which is just to swap the sign of that. And you have the bottom multiplication, which is root 3, that by that, minus 3. Okay, 3 take 1 is 2. won't go any further. And simplify by rationalizing the denominator. Well, it will go further. They're saying, please do root 3 plus 3 over root 3 plus 3, which is 3 minus 9 minus 6 at the bottom. Now, I've that by that, which is 3. I've that by that, which is 6. I've 2 root 3's and 3 root 3's, which is 5 root 3. 9 plus 5 root 3 over negative 6. And you're not allowed to leave a negative downstairs, just as much as you're not allowed to leave a surd downstairs. So we'll call it negative 9 plus 5 root 3 over 6. You'd be tempted to distribute in a 3, but then you're going to end up messing this up, so you leave it there. Just check that one at the very back, and then I'll park it. Minus 9 plus 5 root 3 over 6. Yeah, they distributed in the minus, but that's fine. Okay, that was another long one. As I say, you got a lot of work to do over the weekend. And during next week, we'll have a few days more class and study. And we'll get this chapter finished, and we'll review some of the early sections that I mightn't have made great YouTube videos for. And furthermore, although I'm not going to put it on the test, but yeah, what we'll do is we'll finish up this chapter as a whole, and then if we're ahead of ourselves, we might just jump back over anything in chapter 1 that you might like to review. See you in the next one.